Hello everyone. Today I want to present an application of YOLO, and title of my this presentation is Deep Learning Based Road Surface Distress Detection from Video Surveys using YOLO. So I will identify and detect road surface distress detection, road surface distress from the video streams using YOLO, and YOLO is a deep learning model, as we know. This is the outline of my presentation. It consists with four parts actually. Firstly, the problem statement, then literature review, method selection, and lastly, the experimental design. Since it's a proposal presentation, so I only cover these four parts of my V component of research paper. This is the background. So firstly, the road infrastructure deteriorates due to traffic. There are some environmental issue, and aging of materials is another factor. And some of the most common road surface distresses are potholes, longitudinal and transverse crack, alligator crack, patching and raveling. And it is necessary to identify those distress as early as possible so that it ensure road safety and also ensure cost-effective maintenance strategy. We can see some pavement distress types here. That is pothole, then alligator, longitudinal cracks, raveling, transverse crack, and patching. We can see six type of distresses, and these are the representative pictures. And there are also some representative pictures I am providing here. We can see another six representative pictures of the previous types, another different types of pictures as pothole, patching, raveling, alligator, longitudinal, and transverse crack. We can see the pictures of different type of cracks and pavement distresses. And let's talk about the traditional pavement inspection. Traditional inspection methods actually involve manual visual survey. Field inspectors record defects and photographic documentation are stored. And the limitation of the traditional pavement inspection are it labor intensive and subjective, because person to person it may vary, and limited coverage because of shortage of inspectors, and safety risk due to traffic, near traffic inspection for the inspectors. Uh, we know there are several pavement inspection standards. I mentioned here four, but there can be more than 100. Long-term pavement performance distress identification manual provided by Federal Highway Administration. They use standard distress classification. Then Oregon DOT and Washington DOT have some manuals on pavement data collection and pavement surface condition field rating. Those use measurement and surface condition rating. And for developing countries, World Bank and Organization of Economic Cooperation and Development has a road monitoring manual of volume 1 and 2. Those can be used for developing countries, pavement inspection. And here comes the role of computer vision. Computer vision can automate the pavement inspection. Large scale road monitoring, we can do large scale road monitoring, and best part is faster analysis and reduce manual effort. And deep learning models can analyze image, video streams very quickly and automatically and detect defects. Deep learning monitoring. Now let's talk about deep learning techniques, especially the convoluted neural network uh, involved here, and it can extract features, detect cracks, and classify distress. Advantages is automatic, its accuracy is high, and is robust in detection performance. And here comes the object detection models. There are several deep learning based object detection models. One is faster RCNN. R represents as region-based convoluted neural network. It is two-stage method. Its accuracy is high but is slower. There are SSD, that is single shot multi-stage single shot multiple detection SSD model. This is single stage, is faster but its accuracy is moderate. Uh, Comparing to the above two, there are YOLO model which is single stage and it can detect real time, can detect object real time. So this is more popular nowadays. And YOLO is the abbreviation for you only look once. It treated object detection as a single regression problem, can detect in one forward pass. Is can detect with high speed and with accuracy, with better accuracy. Advantage is real-time detection, as I mentioned, that real-time detection is the most advantage of YOLO. And best part is it is suitable for video processing and multiple object detection can possible in YOLO model. Then if we look at the literature review summary of my research proposal, there are PNN classifier which use automated survey data, improve distress detection technique, also deep learning models which use the street view images and effective pavement condition can be easily assessed. And there are yellow method. Yellow method is adopted by one paper of 2020, which use pavement dataset and if you can efficiently detect the distress. If we look the yellow-based studies, there are numbers of yellow-based studies. I have presented 5 of them here. Some of them use yellow 5, yellow 8 models. Those are older model, and in my paper I propose yellow V11 or yellow version 26, which are most up to date. In 2022, we can see that the anchor optimization, that is optimization technique are used with yellow, and some of the paper improved yellow models. They can detect even small cracks, and some deals with multi-country data set and multi-scale feature extraction and fusion techniques are adopted in a paper. And Young and Lee in 2024 use the attention mechanism which can improve the existing yellow detection model's performance especially. And there are some advanced model, generative adversarial network, gen-based model, which can create synthetic data set, and also mobile crack for mobile version, so that lightweight CNN can be used for mobile to detect cracks. These models can improve dataset diversity and enhance computational efficiency. And research gap, though there are significant progress, we can see there are several limitations. Many studies use static image. They do not use videos, and sometimes difficult to detect fine cracks, and limited for environment, limited for generalization across different types of environments. And sometimes, not only sometimes, most of times, there is a deficiency in integrating the computer vision models with standardized distress manual. So my target is to integrate with standardized distress standardized manuals, so that visual inspection will become fully automated, computer based and fully automated. And here comes the research objectives. The study aims to develop yellow-based deep learning models, and I will use video survey data, classify distress types, following the standard manuals, and lastly, evaluate the detection accuracy using standard performance metrics. This is the methodology overview. Firstly, the video data will be collected, then feature will be extracted, then image will be annotated, and data augmentation technique is applied. The most important part is then I will use YOLO model training. Lastly, performance evaluation will be checked. These six, total 6 steps I will follow for this research workflow. You can see the infographics over here. Then comes the YOLO architecture. YOLO architecture or frame consists with 3 parts. One is backbone, neck, and head. The backbone is the feature extraction. Neck is the fusion of those features in multi-scale perspectives. And detection head is the object classification and localization process. These 3 parts consist the YOLO architecture. Uh, this part I will discuss on the data set preparation. The data set will be collected from vehicle mounted camera videos and various light condition and road environment. I will consider total 10 to 15,000 uh, frames will be annotated for training, and distress classes will be 6 categories, and the severity level will be in 3 categories. The severity level will be minor, medium, and severe. And distress classes will be pothole, longitudinal transverse crack, alligator crack, patching, and labeling. These criteria I will consider. And data augmentation, if we look at the data augmentation, it will improve the model robustness. Almost 6 techniques I will use for data augmentation, say rotation, scaling, horizontal flipping, brightness and contrast variation, motion blur, and lastly mosaic augmentation I will provide. I will use in my data set. And this is the training setup. I use the 16 batch, divide the data into 16 batch, then learning rate will be 0.001. I take the small learning rate steps so that the model training will be good. And epoch, I will take 100 to 150 image sizes will be taken as a standard for YOLO, that is 640 to into 640, and that I will be split it into training, testing, validating. Training will be 70%, testing will be 15%, and validation will be 15%. And the framework I will use Ultralytics YOLO. Ultralytics is the corporation which developed the YOLO model, and the Python-based framework I will use to access the GPU, graphics processing unit. And this is the model performance matrix. We can see I will measure the model's performance based on precision recall F1 score, mean average precision with threshold 0.5 and threshold between 0.5 to 0.95. The precision is the correctness ratio, and recall is the detection completeness. F1 is the harmonic mean of precision and recall, and detection accuracy and overall performance will be assessed by mean absolute precision thresholds. And this is the expected contribution of my research. I want to automate the video-based pavement distress detection and integrate these with the standard distress classification manual, and it will be scalable for road monitoring and support infrastructure, overall infrastructure maintenance, because especially for the preliminary assessment, visual assessment, it is better to use automated method than to manual visual assessment. So this is the best part of this research proposal. And this is the reference paper that I have gone through. This is all the reference paper I have mentioned here. And lastly, thank you so much for giving attention.